All right, today's video is chemical equations part 2. If you don't speak French, that's okay, neither do I. And what we're going to talk about today are adding a little bit more information to what we talked about yesterday and how to write a chemical equation, what the symbols mean, and we're going to make it a little bit more robust today. But before we do that, I want to share with you my favorite comic strip of all time, and this is The Far Side. Hopefully some of you still enjoy this. I don't know if it's lost on your generation, but for me this is classic humor, and you can see here, if you have a dog, this is pretty funny. Okay, so let's take a look at a chemical equation. So I'm going to write this here. K plus H2O forms H2 plus KOH. So we talked yesterday about this type of reaction, and we remember that these are the reactants and these are the products. You can look at the arrow, and the direction the arrow is going will tell you which side is reactants and which side is products. If the arrow was going the other way, then these would be the reactants and these would be the products. So how we would read this from yesterday, we would read this as potassium. You can look on your periodic table for the symbol of potassium, and notice it's by itself and it's not one of the 7 Brinkelhoff elements, so you just write one potassium. Potassium reacts with water, or dihydrogen monoxide, if you want to use that name for it, to form or to produce hydrogen and potassium hydroxide. Okay, this is an ion. You'll look on your ion sheet and you can find out what that one is. Alright, so today what I want to add are what are called the state symbols, and there are 4 state symbols. And what a state symbol is it represents what physical state each substance in an equation occupies. For example, if something is a piece of metal, that's a solid, so it would occupy the solid state. Obviously, if it's a liquid, it's a liquid, and then there's a gas state, and there's a 4th state, which we'll talk about. Let's do this color-coded wise. So if something's a solid, the symbol we use is inside parentheses an S, and I'll show you how to put this up there. This potassium is a solid. It's a metal, so we will give it the state symbol S. So the state symbols always go the lower right-hand side of the number is where the state symbols go. So our next state symbol, we'll do liquid in red, and that's L. Water is a liquid, so we give it the L state symbol. And let's do cyan, yay, for gas. And gas will be hydrogen is a gas. Now you might be asking yourself, well, Mr. Held, how do you know what state something is in? And it's usually will either be told to you in a problem, or as time goes on, you'll be able to start predicting. Like if it's copper, copper's a solid in its natural state, or bromine is a liquid in its natural state, and so on. But for now, you'll know. You'll be told in the problem or otherwise. And then the 4th state is aqueous, and its abbreviation is AQ, and I'll tell you how we know. I just did AG, AQ. How you know that this is in the aqueous state is that the reaction started and there was potassium and there was water. So imagine this is in a beaker. The beaker's full of water, though. That's what this is just telling you, that the beaker's full of water and you dropped a piece of potassium in, and then a reaction occurs. I think we did this in class. We did it with sodium and water, and you see the fire and you see the gas being produced. Well, that's the gas, and what's left over is dissolved in water, and what's left over is this KOH. And since it's in water and it's dissolved in water, we say that's the aqueous state. You could also say aqueous state. For example, how a chemist would say this is NaCl, AQ. This is a chemist's way of saying salt water. You go to the ocean, you could say, man, this salt water really tastes bad. Or you could say, wow, this aqueous sodium chloride solution really tastes bad. It's the same thing. Salt water is NaCl dissolved in water, and so we give it the AQ symbol and it comes in handy for chemists. So finally, how we read this here, potassium, we'd say solid potassium reacts with water, you could say liquid water, it's kind of redundant, but liquid water, to form hydrogen gas, and you could say potassium hydroxide solution, or you could say aqueous potassium hydroxide. Alright, so let's take a look at what happens in a chemical reaction. I've got everything written here and color-coded so you can see the carbon is blue. There's 4 H's attached to it. They're the red atoms, and then the orange is oxygen. So there's oxygen. Now, we haven't talked about this yet, but I want to talk to you about something called the coefficients in a chemical reaction. So what the coefficients are, they tell you how many of each atom you have, or each particle. So they go in front of the symbol, so this will be a 1 because there's 1 CH4, but here there's 2 O2, so we put a 2 there. You can see the 2 O2s right here. Alright, so now, what happens over time? Well, here's what's going to happen. Watch this in slow motion. So at this point, there's a collision between the CH4 and the O2s, and this is what you would be left with. So if you take a look at this, what we're going to be left with, we still have our C, so our C is now attached to 2 O's, so we now have C, and you can see it's attached to 2 O's, so CO2, and what's the other thing we have? That's right, we have water now, so we have H, let's see, H2, there's 2 waters in each of these, 2, and then our O. And then coefficients in front, there's 1 CO2 and there's 2 H2Os. But one thing to notice throughout this whole reaction, the number of atoms didn't change. We started with 1 carbon, we still have 1 carbon. We started with 4 hydrogens, we still have 4 hydrogens, and that's important. In a reaction, the atoms are always conserved. They don't just disappear. So keep that in mind. And this is your first look at what's called a balanced reaction. And what that means is the number of atoms that we started with, okay, equals the number of atoms we end with. So there's 1 C here, there's 1 C here. 4 H's, there's 2 times 2, which is 4. H is there. There's 4 O's here, 2 times 2 is 4. And then there's 2 there, 2 there. So it is balanced.